Okay, so in this lecture I want to talk about differential equation. So here's a differential equation, a very basic one. It has derivative of y and times by xy. So it looks like an implicit equation with derivative combined with the normal function itself. Okay. So in a way, we're trying to actually find the antiderivative of implicit equations. You can think of it that way, okay, as an algebra question. The official definition is it's an equation, it's a function which contains unknown functions and one or more of its derivatives. Now these are even more tricky to find the antiderivative than the functions that are stated explicitly. So this is a relatively easy one. Let's try this. So we have y prime is equal to xy. Okay, so that's essentially dy over dx is equal to xy. So we want to collect all the x's together and the y's together. So we have dy, okay, times by 1 over y. If you bring this y over to the left side, and x times by dx. So this is then ln of y, absolute value of y actually, and this is half of x squared plus some constant. Okay, so if you isolate y, you get e to the power of half of x squared plus some this plus constant. I'm going to write that as just a, where a is e to the power of c. Okay, so we call this right here, this does as a solution of the differential equation. Okay, but unfortunately not all actually a lot of the differential equations is not this easy to solve. Okay, and we need a lot of times we need actually other numerical methods to figure out what's going on with this particular curve.